You're welcome back to this channel. In today's class, we want to determine the eigenvalues and eigenvectors for this square matrix A. The first thing that we need to do is to find the eigenvalues, and we have to follow some steps. Those steps are, the first thing is that you have to multiply lambda by an identity matrix. The order of this identity matrix can only be determined by the order of this square matrix A. This square matrix A is 3 by 3. That means identity matrix A must be 3 by 3 as well. So lambda multiplied by 1, 0, 0, 0, 1, 0, 0, 0, 1 will be lambda 0, 0, 0 lambda 0, 0, 0 lambda. So that means I use lambda to multiply all the elements of this identity matrix. So the next thing is to take A minus lambda.I. So A matrix A is 2, 0, 1, minus 1, 4, minus 1, minus 1, 2, 0, then minus lambda 0, 0, 0, lambda 0, 0, 0, lambda. So from here we have 2 minus lambda is 2 minus lambda. 0 minus 0 is 0. 1 minus 0 is 1. Minus 1 minus 0 is what? Minus 1. 4 minus lambda is what? 4 minus lambda. Minus 1 minus 0, minus 1. Minus 1 minus 0, minus 1. 2 minus 0, 2. 0 minus lambda, that is minus lambda. So that is our A minus lambda.I. So the next thing is to find the determinant of A minus lambda.I. So determinant of A minus lambda.I is going to be determinant of 2 minus lambda, 0, 1, minus 1, 4, minus lambda, minus 1, minus 1, 2, then minus lambda. And we need to find the determinant of this 3 by 3 matrix. So let's put sign on top, plus, minus, plus. So here I have, we take plus 2 minus lambda. So 2 minus lambda multiplied by, you cover it horizontally, you cover it vertically. So we are left with 4 minus lambda multiplied by minus lambda. Then minus 2 multiplied by minus 1, that is minus 2. So multiplied by minus, that is plus 2. So that is for that. Then minus 0. Minus 0. You cover it horizontally, you cover it vertically. So we are left with minus 1 multiplied by minus lambda, that is plus lambda. Then minus 1 multiplied by minus 1, that is 1. So minus 1. So plus 1 here. Cover it horizontally, cover it vertically. So you have minus 1 multiplied by 2, that is minus 2. So you have minus 2. Then minus 1 multiplied by 4 minus lambda. So we have, this is equal to 2 minus lambda multiplied by, let's expand this. 4 multiplied by minus lambda, that is minus lambda, or minus 4 lambda, minus 4 lambda. Then minus lambda multiplied by minus lambda, that's plus lambda squared. Plus lambda squared. Then plus 2. The whole of this one is going to give us 0 because it's multiplying by minus 0. So I have plus 1 into brackets. Here I have minus 2. Then 1 minus multiplied by minus 1, that is plus 1. Plus 1 multiplied by 4, that is plus 4. So plus 4. Then plus 1 multiplied by minus lambda, that is minus lambda. 2 minus lambda into brackets. Let's rearrange. We have lambda squared minus 4 lambda plus 2. So let's simplify this one. So we have plus 1 into brackets. Minus 2 plus 4, that is 2. Then minus lambda. So from here, let's use open brackets. So if we multiply by 1, we have 2 minus lambda. You can see that 2 minus lambda is in the first expression here. 2 minus lambda is also in the second expression. So that's why you can factorize 2 minus lambda out. So let's factorize 2 minus lambda out. We have 2 minus lambda into brackets. Lambda squared minus 4 lambda plus 2. Then if you factorize 2 minus lambda out here, we have 1. So plus 1. So now I have 2 minus lambda into brackets. Lambda squared minus 4 lambda, then plus 2 plus 1 plus 3. Now, determinant of A minus lambda.I, let's equate it to be equal to 0. That is what characteristics equation. Characteristic equation. So now, and we have gotten our determinant of A minus lambda.I to be equal to 2 minus lambda into brackets lambda squared minus 4 lambda plus 3. So everything is equal to 0. So from here, we can say that 2 minus lambda is equal to 0. Then lambda squared minus 4 lambda plus 3 is also equal to 0. So from here, 2 is equal to lambda. That is our lambda one. Or just name it, leave it like this. So the first lambda is equal to 2. So now let's solve this quadratic equation. Lambda squared minus 4 lambda plus 3 is equal to 0. It is factorizable. So we have lambda squared minus, I need 2 factors of 3 lambda squared. That if I add together, I'll have minus 4 lambda. And that will be minus 3 lambda minus lambda. So minus 3 lambda multiplied by minus lambda is going to give me what? 3 lambda squared. Then if I add it together, minus 3 lambda minus lambda is going to give me what? Minus 4 lambda. So then plus 3 is equal to 0. So from here, I have lambda into bracket lambda minus 3 minus 1, then lambda minus 3 is equal to 0. So lambda multiplied by lambda squared. Lambda multiplied by minus 3 lambda. Minus 1 multiplied by lambda, minus 1. Minus 1 multiplied by minus 3 plus 3. That means we are correct. So now I have lambda minus 1 into brackets. Lambda minus 3 is equal to 0. So that means lambda minus 1 is equal to 0, or lambda minus 3 is equal to 0. So I have lambda is equal to 1, then lambda is equal to 3. So don't forget I have lambda is equal to 2 already. So from here I can now say that lambda is equal to 1, 2, 3. So that is the eigenvalues. So we can say that eigenvalues are 1, 2, 3. So having gotten our eigenvalues, we can now find the eigenvector. Eigenvectors. Recall this equation. Ax is equal to lambda x. So from here, we say that we need to multiply the right hand side by I, which is identity matrix. So we have Ax minus lambda xi is equal to 0. From here, let's factorize x out. We have A minus lambda I multiplied by x is equal to 0. So this is what we want to use to find x, because x is the eigenvectors. So this is the formula that we need to use now. Now, what is our A minus lambda I? But we have to use that lambda for each of these eigenvalues. So we now say that for lambda 1 to equal to 1, what will be the eigenvectors? So from here, we recall that we have our A to be equal to 2, 0, 1 minus 1 something. So we have A minus lambda I, which will be 2 minus lambda, then 0, 1, minus 1, 4 minus lambda, minus 1, minus 1, 2, then minus lambda. Then multiply by this x will be x1, x2, x3, because we have to write it in matrix form. Is equal to, let's write 0 in matrix form as well. 0, 0. So that is column matrix. So from here, what is the value of our lambda here? Value of lambda is 1. So let's substitute the value. So I have 2 minus 1, that is what? 1. Then 0, 1. Minus 1. 4 minus 1, that is 3. Then minus 1. Minus 1, 2. Then minus lambda, that is minus 1. Then multiply by x1, x2, x3 equals 0, 0, 0. So let's do the multiplication. So the first row to multiply this column matrix is going to be 1 multiplied by x1, that is x1, plus 0 multiplied by x2, that is 0. So that is 0, plus 1 multiplied by x3, x3 is equal to 0. So from here, I have x1 plus x3 is equal to 0. So I can say that x1 is equal to minus x3. Row 2 multiplied by this column matrix. That will be minus 1 multiplied by x, that is minus x1, plus 3 multiplied by x2, that is plus 3x2, minus 1 multiplied by x3, that is minus x3, is equal to 0. Also, row 3, minus 1 multiplied by x1, that is minus x1, plus 2 multiplied by x2 plus 2x2, minus 1 multiplied by x3, that is minus x3, is also equal to 0. So now recall that x1 is equal to minus x3. So anywhere we say x1, let's put minus x3 there. From equation 2, let's take equation 2. So we have minus x1 is what? Minus x3. Then plus 3x2 minus x3 is equal to 0. So this gives me minus multiplied by minus x3, that is x3, then plus 3x2 minus x3 is equal to 0. Plus x3 cancel minus x3. I have 3x2 is equal to 0. So divide both sides by 3. That means x2 is equal to 0. So now, and from here, x1 will be the coefficient of x3. So x is equal to minus 1, 0, 1. So this x is corresponding to lambda 1 is equal to 1. So for lambda 2 is equal to 2. Let's see what happens. We're still using a minus lambda I multiplied by x is equal to 0. So from here, we have our a minus lambda I, which is 2 minus lambda 0, 1, minus 1, 4 minus lambda, minus 1, minus 1, 2, minus lambda, multiplied by x1, x2, x3 is equal to 0, 0, 0. And here our lambda is 2. So we have 2 minus 2, that is 0, 0, 1, minus 1. 4 minus 2, that is 2, minus 1, minus 1, 2. Then minus lambda will give me what? Minus 2. Then multiply by x1, x2, x3 is equal to 0, 0, 0. So let's multiply. 0 multiplied by x1, that is 0, plus 0 multiplied by x2, that is 0, plus 1 multiplied by x3. So that means x3 is equal to 0. So x3 is equal to 0. So minus 1 multiplied by x1, that is x1 minus x1. 2 multiplied by x2, that's plus 2x2. Then minus 1 multiplied by x3, that is minus x3 is equal to 0. So from here, let's substitute the value of x3 there, which is 0. So the whole of here will be 0. So we have minus x1 plus 2x2 is equal to 0. So from here we have 2x2 is equal to x1. So that means x3 is equal to 0. So x2 will be the coefficient of x1, which is 1. So that means x2 is equal to 1. And x1 will be the coefficient of x2, which is plus 2. So that means x1 is equal to 2. Now we can now say our x. So let's call this one x1. So let's call this one. The second one will now be equal to 2. x1 is 2, x2 is 1, and x3 is 0. So this is corresponding to lambda 2 is equal to 2. For lambda 3 is equal to 3. So we are still using a minus lambda I multiplied by x is equal to 0. And now a minus lambda I is 2 minus lambda 0, 1, minus 1, 4, minus lambda, minus 1, minus 1, 2, then minus lambda, multiplied by x1, x2, x3 is equal to 0, 0, 0. And here our lambda is 3. So we have 2 minus 3, that is minus 1, 0, 1, minus 1, 4 minus 3, that is 1, so minus 1, minus 1, 2. Then minus lambda, and our lambda is 3, so I have minus 3 here. So multiply by x, multiply by x1, x1, x2, x3 is equal to 0, 0, 0. So now let's multiply. The first row, minus 1 multiplied by x1, that is minus x1. Plus 0 multiplied by x2, that is 0 plus 0. So plus 1 multiplied by x3, so plus x3 is equal to 0. So from here, our x3 is equal to x1. So we have minus 1 multiplied by x1, that is minus x1. Then plus plus 1 multiplied by x2 plus x2. Then minus 1 multiplied by x3, that is minus x3 is equal to 0. So that means x3 is equal to 2, 4, 2. So what this means is that this is corresponding to lambda 3 is equal to 3. We can see that our eigenvalues are 1, 2, and 3. And the eigenvectors, we have the first one, we have minus 1, 0, 1. The other one, we have 2, 1, 0. Another one, we have 2, 4, 2. So you can check whether you are correct or not if you use Ax is equal to lambda x. So when we have minus 1, 0 something, so we have 2, 0, 1, minus 1, 4, minus 1, minus 2, minus 1, 2, 0. Then multiply by the eigenvectors we've got there, minus 1, 0, 1. So it has to be, our eigenvalue there is 1. So then multiply by minus 1, 0, 1. So at the end of the day, if you multiply this one, you have to get this. This 2 multiplied by minus 1, that is minus 2. Then 0 multiplied by 0 plus 0. Then plus 1 multiplied by 1, that is plus 1. That is what? Minus 1. You can see that if you open this one, you still get what? Minus 1. That means that is correct. That is correct. So this one is scalar. That is from this value of the x, there is something that we can still multiply, we can factorize from this value that we still get the same answer for ax. Let's do for the other one. We have minus 1 multiplied by minus 1, that is 1. Then 4 multiplied by 0, that is 0, so plus 0, 1 plus 0, then minus 1 multiplied by minus 1 multiplied by 1, that is minus 1. So that is what? 0. 1 minus 0, 0. If you multiply this one, so it's what? 0. So if you do for other one too, so that means everything here is correct. So till I see you in the next class. Bye bye.